This is our project-based learning on earthquake slideshow. At the beginning of the year, Mr. Hartman presented us on something called a PBL. PBL stands for project-based learning and is a more in-depth type of learning that teaches us a lesson through projects. There are steps to an entry to a PBL, which includes an entry event, making a plan, and understanding what we did and applying it to the real world. The way that we did an entry event was we watched a video and we learned a few stuff before we started, and what we learned was like 21st century skills, and 21st century skills are critical thinking, inquiry, and collaboration. 21st century skills are skills used in day-to-day life that you need, and some outcomes, we have them on the board here, give like students, they're innovative and more creative. They usually have more access to tools and resources. They have way better connections emotionally and socially with people, and that's what 21st century skills are.
So we built an earthquake resistant structure and a shake table. Basically, a shake table is a table that represents an earthquake. Our structure is a arc bridge, but we couldn't actually build an arc bridge because Legos don't come in triangular form. So that's what it needs to make a keystone. We chose Zimbabwe. Not many people think that Zimbabwe has a lot of earthquakes. We chose jello jigglers as our ground. It's more sturdy, and we built the bridge 2 blocks wide out of Legos because it's more durable to a 7.0 magnitude earthquake. We mounted the bridge in the jello jigglers, and yeah. So this is our bridge. It's mounted in the jello jigglers, which is the blue right there, and around it is what it sets in. It's like a tinfoil kind of thing. To the left is our arc bridge. Under it is our bridge. This is Zimbabwe, the little green dot right there. This is Zimbabwe flag, and picture of Legos and jello jigglers.
A couple things we had to learn was what seismic waves are. Seismic waves are waves of energy stemming deep into the earth, which when tectonic plates rub against each other, which creates an earthquake. The main 4 types of seismic waves are primary, secondary, love, and Rayleigh. Secondary waves move in a back and forth motion, as do primary waves, which move in a side-to-side motion. Rayleigh waves move in a rolling motion, and love waves move in a similar way to secondary waves, but in horizontally. Faults are a break in tectonic plates, and tectonic plates are large puzzle pieces that make up the earth. Alright, plate boundaries. Plate boundaries are the edges of tectonic plates. There are 3 different types of plate boundaries, which is convergent, divergent, and transform. Divergent plate boundaries move away from each other, convergent plate boundaries move inward, creating a mountain, and transform boundaries slip past each other. We did a demonstration for Oreo cookies, and transform boundary, as you can see, they slip past each other. Convergent boundary, they come inward, creating a mountain, and divergent boundaries move away from each other. Another thing we had to learn was the focus and the epicenter. The focus is the point when the earthquake happens in the beginning. The epicenter is where 2 tectonic plates rub against each other directly above the focus on the surface.
We had a lot of important information we needed to know. We needed to know this information because without knowing what it was, we wouldn't be able to do the project. Some of the things we need to know are what is an earthquake, how seismic waves move, what they are, how many they are, what are plate boundaries, where they at, and how is this information in the real world. So that's what we did. First we had to choose a structure we came up with some ideas. The first idea we came up with was using a piece of cardboard and then taking spin brushes and put them underneath it to simulate S&P waves. The second thing we did was we didn't like that idea, so we came up with another idea of using Jello jigglers and putting our bridge inside that to simulate S&P waves. We gave our presentation, and then we realized that there is no structure that is resistant to an earthquake. Our structure stayed standing.
Along the way, there were some good things and there were some bad things. Some good things that had happened as we were going through the presentations where we turned in our shake table on time, our structure stayed standing during the simulated earthquake, and the Jello jigglers proved to work well as a shake table and to hold up our bridge. The things that we aren't very proud of are some of the arguments we had, and then we also had very bad time management. We turned things in on time, but we were doing them last minute. We had very bad eye contact with the audience, and then when we were explaining things, it wasn't very thoroughly, it was very vague.
So, in conclusion, we built a bridge because of our PBL assignment, answering the question, what structure is most resistant to an earthquake? We built our bridge into Jello jigglers because the Jello jigglers are strong and the Legos were strong too. They linked together. And after simulating it and testing it and going back, we realized that there's no structure that is most resistant to an earthquake. We had to look back at our terms to understand this and other people's projects that we watched. And we decided that it just depends on how you build it. If we would have built it a different way, or with a different material, our bridge may have not stood, but it did because of the way that we built it.
In order to know all the information we needed to know, we used books, the internet, and professional people. The books that we used were Inside the Restless Earth, The Earth, and Science Easy. For the internet, since we didn't want to use Wikipedia or Ask.com, we used National Geographic and news sites because we didn't want information that was dated probably like 10 years ago or something like that. Doug Dietzel helped us explain what an earthquake is and how it moves and stuff. He has a bachelor's in art and sustainability and science and biology. He also has 2 minors, and then he will soon be receiving a master's in environmental geology. Mr. Hartman had also helped us come up with more successful ideas for a shake table. Mr. Dietzel explained that on a arc bridge there's a keystone and it's like a triangle form, and when you push down on the keystone, the pressure spreads throughout the bridge and eventually will collapse. Our bridge did not have it, but it was still staggered like it, but there was no certain spot where you push and it collapses. And he had taken mechanical engineering courses in order to know all